Hello, and welcome to Astronomy 100. In this segment, we're going to continue with our discussion about the origins of understanding of astronomy. And if you recall, what we're doing is establishing how the early people, the early cultures of the Earth, were able to figure out some very basic things about our universe, things that we take for granted today, but nonetheless were very difficult for them to be able to figure out and have led to our understanding of astronomy today. In our last segment, we talked about how the ancient people of the Earth could not figure out whether or not the Earth was a moving body or was it a stationary body. And so because they couldn't convince themselves that the Earth was a moving body, they formulated an explanation of the universe surrounding this concept of a stationary Earth. And so everything that they explained about the movements of objects in the nighttime sky were centered on this concept of the Earth being stationary and the center of the universe. So if we go to this illustration from last time, if you recall, it was Aristotle, one of the early Greek philosophers, who came up with an explanation that the Earth is the center of the universe and that the planets themselves are attached to a small circle called an epicycle. The circle itself, the epicycle, was attached to a larger circle called a deferent. And when we make the planet move on the epicycle along with movement along the deferent, what we end up getting is that the Earth, at the center of all things, is able to witness a planet go forwards and backwards and forwards, matching what we see in the sky. And if you recall, this is called epicyclic motion. Now, as history progressed, there was a need to modify this to accommodate something else that is visible when you look at some of the planets in the nighttime sky, in particular the planet Mercury and the planet Venus. So let me show you a picture to start with. This is a composite photograph of the planet Venus, and this is what you actually see over a lengthy period of time if you were to go outside and photograph Venus night after night after night. And so each of these little dots that look like stars are actually the planet Venus. And what this photographer did was he went outside, took a picture of Venus, waited a few more days, took another picture of Venus, a few more days, and another picture, and so forth and so on. And what you can see is, looking towards the western horizon here, this is the city that he lives in, night after night after night, you'll notice that Venus rises higher and higher and higher in the sky, and it moves a little bit each night. Remember, planets were wandering stars. And you can see that Venus will turn in its path that it's making against the background sky, and then turn and get lower and lower and lower, and ultimately disappearing from the evening sky. And so if we were to create a diagram to show you all of this, this is sort of what we're talking about. Venus appears either shortly after sunset during certain times or shortly before sunrise. And if you look at the sky and find Venus shortly after sunset, what you'll find is that Venus will rise higher and higher above the horizon each night that goes by, and then it turns, and then it gets lower and lower as each night goes by. And the whole thing takes a few months for Venus to steadily work its way up higher, and then turn, and then steadily work its way lower. And by the way, Mercury does exactly the same thing. The only difference, though, is that Mercury doesn't get as high in the sky as Venus gets. So Venus is always close to the Sun, Mercury is always close to the Sun, and both of these planets are only visible shortly after sunset. You'll never see them late at night, or you'll never see them in hours long after sunset. Now, what's interesting is when Venus and Mercury disappear from the evening sky, they appear in the morning sky. And what will happen is in the pre-dawn hours and the hours before sunrise, you'll watch Venus get higher in the sky, turn, and then get lower in the sky. And Mercury will do the same thing. And if you recall from our previous segments, the terminology is this is Venus showing you direct motion, and then when Venus turns and starts to reverse, this is retrograde motion. So the ancient people of the Earth, the ancient Greeks, were confused by this. They didn't really know why Venus and Mercury are always very close to the Sun and why they're only visible shortly after sunset or shortly before sunrise. So in the 1st century AD, a Greek philosopher named Ptolemy comes along to explain this. And let me show you a diagram as to how he explains this phenomenon. When you look at both of these together, there's an obvious clue. What we're actually seeing is that Venus and Mercury are demonstrating that they're orbiting around the sun. So when you see them in the evening sky and then see them in the morning sky, put these two illustrations together, and what you're seeing is Venus and Mercury orbiting around the sun. But remember, the ancient Greeks would not accept the idea of anything orbiting around the sun because to them everything orbits around the Earth. So what was an explanation to sort of fix this was the belief that when you were looking at Venus and Mercury, you were actually seeing them from the perspective of the Earth on their epicycle. So here's the epicycle of Mercury, here's the epicycle of Venus, and you'll notice if we were to animate this, you would see Venus going around and around and around. But to keep Venus and Mercury on one side of the sun or the other side of the sun, either in the evening sky or in the morning sky, it was believed that there was some force or some property of our universe that was keeping these two epicycles permanently locked between the Earth and the sun. And the person to come along and explain this phenomenon was Claudius Ptolemaeus, otherwise known as Ptolemy. And here is what we call the Ptolemaic system, where you can see the Earth as the center of the universe. You can see the sun moving in its orbit around the Earth. Remember, they had this backwards. In reality, it is the sun that is the center and the Earth that goes around the sun. But they have the Earth as the center of the universe, and you can see that they have the epicycle of Venus, the epicycle of Mercury, permanently locked between the Earth and the sun. Now, they gave no explanation as to what would keep these two epicycles permanently locked between the Earth and the sun, but they just figured it was the work of, or the will of the gods. So this forces these two planets to match what you see in the sky. Ultimately, this is the original epicyclic motion system or model that was created by the Greek philosopher Aristotle, but it is Ptolemy who comes along and modifies this to include the observed movements of Mercury and Venus. And this Ptolemaic system would end up being the believed and accepted explanation of how the universe operates for a very, very long time, for a total of almost 1,500 years following the work done by Ptolemy. Now, there were four basic ideas that go along with this particular concept, and I'm going to summarize them fairly quickly for you here. The first two go with the basic idea of geocentrism. The ancient people of the Earth believed that the Earth was the center of the universe and that all celestial bodies revolve around the Earth. So these two go together, they work together to essentially support the geocentric model. The third rule of the Ptolemaic system was that all celestial bodies were deemed to be perfect and that they had movements that never changed or that they had appearances that never changed. The belief that the universe was an eternal place, that when you notice that there are things in the sky moving, they move in a very predictable way, they move in a very mechanical way. The moon shows phases over a period of time, but then repeats and continues to show those phases and repeats. The movement of Venus, the movement of Mercury is the same, systematically moving and repeating. So the ancient Greeks had this belief that all of this was something that had been happening forever in the past, all the way to something that will continue forever in the future, that the universe was just not a changing place, that it was eternally doing what you witness it doing. In reality, we know this is not true. We know that the universe does change, that stars live and die, and the stars that we see tonight will not be the stars of the universe in the far future. But you can imagine over a short human lifetime that this is something that just won't be understood. Over a human lifetime, the stars that you see on the day that you were born will be the stars that you see on the day that you die. And your grandparents see the same stars that you see. So there's this belief that the universe is an eternal place that doesn't ever seem to change, that it just seems to do what it does, and it has been doing so and will continue to do so forever. Now, the perfection part of this particular statement is the ancient people of the Earth believed that the planets, the moon, the sun, were all in the realm of the gods, and so only the gods would have a universe that would be a perfect place. If you've ever read any mythology, the gods themselves are always portrayed as being perfect individuals, perfect strength, perfect beauty, and so if the gods themselves are very perfect, then of course the universe that they live in and the celestial bodies of that universe will be perfect as well. The fourth rule is actually a very significant one. This assumption about the universe was that when you look at the bodies of the heavens, the celestial bodies, the way that they move seems to have two components to it. The first component is that when you look at the objects of the heavens, you'll notice that they always seem to move in a uniform fashion. And the use of the word uniform in this case means that the speeds of the objects are always the same. Nothing ever speeds up, nothing ever slows down. So any movement that is continually the same speed would be considered uniform motion. But it was also uniform and circular motion. The epicycles were perfect circles, the deferent was a perfect circle, the earth was a perfect circle, the sun a perfect circle, the moon a perfect circle. Now, why this obsession with perfect circularity or a perfect circle to describe the objects of our universe? Well, this has some telling components to it as to what the motivation was for the ancient Greeks. So let me show you a particular picture here. In ancient Greek geometry, one of the particular shapes that has some deep significance is the circle. If you think about the circle, it is very different from all other shapes. If you compare the circle to a triangle or to a rectangle or any other polygon from geometry, you'll notice that the circle has no corners to it. It is a continuous line, no beginning, no end to it. The distance from the center of the circle to the edge of the circle is the same in all places. So these are properties that makes the circle unique compared to all other polygons in geometry. But what really made the circle mysterious to the ancient Greeks was when you determine or measure what is called the circumference of a circle, and you measure what is the diameter of the circle, when you compare the two as a ratio, the circumference divided by the diameter, you end up getting the number 3.14159, et cetera, et cetera. It's a number that is very, very large with no end to it. And you might recognize this number as what we commonly call the number or the constant called pi. The reason why this was mysterious to the ancient Greeks is because even if you have a larger circle, you have a larger circumference, but you also have a larger diameter, and when you compare the two, you still get the same number. When you have a smaller circle, you have a smaller circumference and a smaller diameter, but the ratio of those two is still the same number. So to the ancient Greeks, this mysterious nature to the circle, this property of circles that no other geometric shape has, means that there must be something about the circle that is the work of the gods. And so the circle itself was believed to be the gift of the gods. And so when you describe the movements of objects in the sky, the assumption is circular. When you describe the shapes of objects in the sky, the assumption is circular. And so there was no reason for the ancient Greeks to believe otherwise. And this assumption about the shapes and the movements and the fact that to them that the earth was the center of all things, these are all ideas that were not proven to be true, but were assumed to be true. But because the ancient Greeks were not doing science, they were not actually employing the scientific method, they had no reason to doubt these four assumptions. And so these four rules of the Ptolemaic system ended up being considered to be fact and would also be considered to be true for many hundreds of years following the life of Ptolemy. And what we will find is it will actually take centuries of effort to try to show that these four assumptions are simply not true and that the universe that we live in is a very different place. It is not this geocentric universe that had been assumed to be true all along, but it is one where the sun is the center of all things. And when we get to these future topics, we'll see slowly how these four assumptions of the Ptolemaic system fall apart. And when we start to employ the scientific method, we can prove that these four rules simply aren't true. Now that's all the time that we have for this particular segment. In the next segment, what we're going to do is talk about how these assumptions would withstand the test of time, and then also the people who will come along to try to work to make sure that we have a correct understanding of the universe, which ultimately leads to what we understand today. I hope you'll join me.